Hi, welcome to what amounts to Unit 8 of AP Physics C. This is the first unit in the electricity and magnetism course. The focus of this unit, again, is going to be electric charge, electric force, and Gauss's law. So here in the first topic, we're going to talk about electric charge and electric force. So something to note is that electric charge is a fundamental property of all matter. So all matter has a charge. For the most part, the charge is going to end up being neutral, right? It is a scalar value, which means we don't care about the direction. The only thing when it comes to positive and negative, that's just telling us that it's either an excess of electrons or a deficit of electrons. And then we have this elementary charge, so all charge is centered around this. So E is going to be 1.6 times 10 to the negative 19th coulombs. And coulombs is the unit of charge. So that actually leads us into Coulomb's law, which describes the electrostatic force between two objects. And mathematically, so the electric force is going to be K Q1 Q2 over R squared. Sometimes this R will be written with a D. But just remember, it's the distance between their centers. So there's something from mechanics that sounds very familiar, and that happens to be universal gravitation. So these are the universal gravitation equation and the electric force equation are very similar in the sense that they look very alike with a constant, two quantities divided by this the distance between centers squared. Because there was an accusation that Coulomb actually just simply plagiarized Newton for this. Now, K is the electrostatic constant. You'll see it sometimes written as 1 over 4 pi epsilon naught. Or if you look at the formula sheet, it'll be written in its true form, which is 9 times 10 to the 9th newtons times meter squared per Coulomb squared. Now, the direction, so something to remember is that most charges are one or the other, or most forces are one or the other. It's attractive or repulsive force. Electrostatic force is both. So just remember the saying opposites attract, likes repel. Okay, so the electrostatic force can cause some of the other forces we talked about in mechanics of tension, friction, and normal force. So they'll maybe they'll say that a tension is created by an electric charge below on another object that can be charged. All right, and then again, I mentioned this before. The electrostatic force is often compared to gravitational force, but again, there are going to be some differences. Gravitational force, right? F equals G M1 M2 over R squared. So you can see they look very similar. Okay, but one has to do with masses, one has to do with charges. So one thing to note, gravitational force is always attractive, where the electrostatic force can be repulsive, right? So it's attractive or repulsive, and that's based on the signs. So repulsive if the signs are the same. So if I have two positive charges or two negative charges next to each other. Attractive if they're different. So if I have a positive, negative. The electromagnetic force is often larger in magnitude than the gravitational force. It's actually one of the strongest of the four fundamental forces. And then the gravitational force acts on a much larger scale, right, than the electrostatic force. So electrostatic force kind of on the microscopic level, the gravitational force on the planetary level. And then the last thing, this epsilon naught, so free space is a constant value of electric permittivity that appears in physical relationships. So this electric permittivity is that epsilon naught. And sometimes they'll call this vacuum permittivity, all right? And it has a value of 8.85 times 10 to the negative 12th Coulomb squared per Newton times meter squared. Okay, so that's what you would plug in. You plug that in, you do 1 over 4 pi times that, you end up with the 9 times 10 to the 9th. Okay, so let's do an example problem looking at electric force. So electric force does use the principle of superposition. So you could be given multiple charged particles that are, affecting each other, and then you have to figure out like what is the force on the middle one, what is the force on the one to the left. They may be in a triangular configuration, right? And so you may have to find the force of the bottom right or the free space. Okay, so let's look at the example. And I apologize for how crazy this goes, but this piece should go here. Okay, and something you see, this is a new kind of thing that AP is starting to push. This is what is called vector notation. So the I hat, J hat, K hat notation. I hat is your X, J hat is your Y, K hat is your Z. So what it is saying that you've got these two charges that are separated, right, in a three-dimensional manner. So one's at positive 4, negative. So if you want to write it as an ordered pair, it'd be like 4, negative 2, 5. This would be 8, 5, negative 9, right? So that's where they're located. So 4 on the X, negative 2 on the Y, 5 on the positive Z. Okay, and then you got 8, positive 5, negative 9. So we know the equation is going to be K Q1 Q2 over R squared. Easy thing are our Q's because they're just straight up like, the only thing we need to do is convert. But remember, micro is times 10 to the negative 6th. Okay, but this is the first thing that we need to find is like, what is the actual distance between them? Now, you can separate this into 3 by just looking at, okay, the X distance, the Y distance, the Z distance. But you can also use the distance formula from math class. Okay, say R is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Right? So even though this is three-dimensional, what you learned in math class holds true, right? You just add in the z direction. So we would do the square root of 8 minus 4 squared plus the 5 minus negative 2 squared plus negative 9 minus 5 squared. And so what we'll find is that this ends up being 16.2 meters. So that's how far they're separated. Okay. And now we can just plug in. So 9 times 10 to the 9th. Now we do 2 times 10 to the negative 6th, right, coulombs. Then negative 4 times 10 to the negative 6 coulombs divided by 16.2 squared. Okay, so note that these two have opposite signs. So these two charged particles will try to attract each other versus push each other away. And so the force ends up being negative 2.74 times 10 to the negative 4th newtons. And again, this negative sign means they are going to attract each other. Okay? All right, so in the next video, we're going to look at conservation of charge and the process of charging, which there's a really cool real-world example for this.